Good morning, students. Today we will start a new topic, that is energy. Now you are familiar about the term force. Okay, what is force? It is a physical quantity which either starts the motion. A football is laid on the ground and a boy came and kicked the football. So on kicking the football moves in the direction of the force. So it starts the motion, it stops the motion, a football is coming towards the player and he blocked the football and stop the football at that place. So on blocking with his leg, he is applying some force. Change the speed or direction or both. That means it is that physical quantity which can change the direction of the moving object. Say football is going in a straight path and a player goes and strike it on the edge, so the direction of the football changes, and if he kicks it hard, then direction as well as the speed both are changed. Change the dimensions of a body. Changes the dimension. Take the sponge and then squeeze it. So you will see that the dimensions of the sponge are changed. And when you release the force, then it again regains its original shape and size. So force is a vector quantity whose SI unit is Newton. Now then we define work. Work, it is the, in your class, it is the product of force and displacement of body in the direction of force for your level. In senior class, you people will learn. So work is equal to force into displacement. Now work is a scalar quantity and its SI unit is joule. Now we come to energy. Now energy is the capacity to do work is called energy. Now, a lot of examples are there in your book. Say a car running on a highway possesses energy due energy as it is doing work. When a boy kicks a football and the football moves in the direction of force, the boy is doing work. Thus, boy possesses energy. A weightlifter raises a heavy load and he is possessing energy because he is doing work while lifting the load. That is, he is changing the position of the load. Now children are playing among themselves, they are doing work and thus they possess energy. Now some persons are doing yoga, they are doing work and thus they possess energy. So from these examples it is clear that any object which is capable of doing work possesses energy. Now work energy relationship, the amount of work done on a body is equal to the amount of energy possessed by it. Say, whenever a person does work an equal amount of energy is used up, and hence he or she becomes tired because he is losing energy while doing the work. So if an object does work, then its energy decreases, and if work is done on the object, then its energy increases. Since work and energy are the same thing, so SI unit of energy is also joule. The SI unit of energy is joule. Okay, other unit. Okay, other units of energy are first calorie and kilocalorie. This we had learned in chapter heat. Now calorie, it is an amount of heat energy required to raise the temperature of 1 gram of water from 14.5 degrees centigrade to 15.5 degree centigrade. That means if we take 1 gram of water at a temperature of 14.5 degrees centigrade and we start giving heat to that amount of water, and as soon as its temperature raises to 15.5 degrees centigrade, so at that time the amount of heat received by that 1 gram of water is equal to 1 calorie. Now 1 calorie is equal to 4.186 joule, or approximately for the calculation we take 4.2 joule. Now kilocalorie. Now in kilocalorie, it is an amount of heat energy required to raise the temperature of 1 kilogram of water from 14.5 degree centigrade to 15.5 degree centigrade. And we all know that the kilo means 1000. Kilo means 1000. So 1 kilocalorie is equal to 1000 calories. Or if we multiply 1000 by 4.2, or we can say that is 4200 joule. Now, various forms of energy. The most important form of energy is electrical energy. Why? Because electrical energy is a form of energy which can be converted into any desirable form of energy using appropriate or suitable appliance. Say, if you need air, so you just switch on the fan. The electrical energy is converted into the rotatory motion of the blades of the fan, and then that blades blow air. If you need light, you just simply switch off the tube light or a CFL or LED, and the electrical energy is converted into light energy. During winter, you need warmth, so you switch on the what? Heater, and then electrical energy is converted into heat energy. So we see that the electrical energy is the most suitable form of energy which can be converted into any desirable form of energy by using a proper appropriate appliance. But there are many other forms of energy, say sound energy, light energy, heat energy, nuclear energy, geothermal energy, tidal energy, and many more. But there are two main forms of energy. The first one is kinetic energy and the second one is potential energy, and together they are called mechanical energy. Say in other unit, electrical energy is calculated in kilowatt hour. The meter which is installed in your home that reads the electrical energy in kilowatt hour. In kilowatt hour means if you use an electrical appliance whose power is 1000 watt for 1 hour, then at that time you are consuming 1 unit of electrical energy. Now just remember, 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule.
Oh, Spiky looks tired. Let's give him something to eat. He seems to be fresh and active now. Do you know why Spiky was feeling dull before he ate the chocolate? This is because he had low energy. We need energy to work, and this energy comes from the food we eat. Energy is the ability of a body to work. There are various forms of energy. Some forms are heat energy, light energy, chemical energy, nuclear energy, electrical energy, sound energy, wind energy, kinetic energy, potential energy, and mechanical energy. Let's identify different forms of energy around us. A family is going on a picnic. It's a sunny day. The sun provides us with two different forms of energy. Can you guess what these are? Heat and light energy. Energy from the sun is called solar energy. Plants use solar energy for photosynthesis. The family is going to the park in a car. How does a car move? It moves because of the chemical energy stored in fuel. In the park, everyone's set up for the picnic while children are playing. Energy is also used to help things move. This energy is called kinetic energy. Now they're sitting at the table. Even sitting down requires energy. The energy of a body when it is at rest is known as potential energy. Now they're listening to some cool music on the radio. It runs on electrical energy from the battery. What kind of energy is the radio producing? Sound energy. Sound energy is produced when an object vibrates and disturbs the air particles near it. Thus, the energy of a vibrating body spreads out in the form of waves. When these waves enter our ear, we can hear the sound. The kids are playing on the swings. How does the swing move? The swing moves using mechanical energy. Mechanical energy is the energy possessed by a body due to both motion and position. Uncle is making a fire in the grill to cook food. What kind of energy is Uncle using to cook the food? He's using fire, which gives us heat energy. Heat cooks our food. It is produced when the particles of a substance start to move faster and faster and start to collide with each other. Look, a kid is flying a kite. How is the kite held up in the sky? By wind energy. Moving air is called wind. What kind of energy can we find in other things or people that were not doing anything, such as grandma sitting on her wheelchair and the trees in the park or Uncle's grill? Do you think they have no energy because they were not moving? Do you remember what kind of energy a body has based on its position? Potential energy is stored in a body which is at rest. Let's summarize. Energy is the ability of a body to work. There are various forms of energy. Some of them are heat energy, light energy, electrical energy, chemical energy, sound energy, mechanical energy, potential energy, kinetic energy, and nuclear energy.